Hello everybody, it's Mr. Ray again with lesson number 6 in our distance learning portion of the course. So on paper it's Unit 3, Lesson 3. So this Unit 3, which is the second part of quadratic equations, there's only 4 lessons, so this is the second last lesson. It's basically a lesson where I'm kind of summarizing everything we've done so far. About finding information about a quadratic so that we can then take that information and be able to find the most important points and do a good sketch or graph of the quadratic equation. The next lesson will be the last one, but it's a big one. It's basically we're going to do applications or word problems related to quadratic equations. What we're going to do this week, this is the second lesson this week. We've had the first 2 lessons were solving equations using graphing and solving equations using quadratic formulas. So the assignment for this week, in week 3, will be on the past 3 lessons. So the solving equations by factoring, solving equations by using the quadratic formula, and this. I will give one more lesson this week on either Friday or Thursday afternoon on getting started with lesson 4 on the different quadratic equations. Different application and word problems. So we'll start off with a few examples. Next week, it's all quadratic word problems. And I'm going to be giving your assignment, I'm going to be giving you a package of word problems. And there's good news and bad news here. The bad news is it's a lot of word problems. If you're like most of the other classes, you're gonna need some help with some of these. So I urge you to join the office hours next week. So that's the bad news. It's going to be a lot of work. It's the end of quadratic, so I guess that's the good part. But another good part is the assignment. I'm just going to be taking selected questions from the package of questions that I'm giving out to practice. So if you do all those questions before Friday, and you're pretty confident you got them right, all the assignment will be doing is basically copying your solutions onto the assignment. Okay, I'm not going to tell you how many there are or which ones they are, of course, but basically if you do all the questions ahead of time, the assignment part will just be basically copying your work from the work that was assigned. Okay, so what this lesson is all about is getting ready for the word problems. So I know it's called graphing quadratic equations, but it could also just as easily be called finding all the key information about quadratic equations. And we're going to be doing these techniques and using the chart that I have here to help you find the information that you need. Okay. So the definitions here, there's really nothing new. It's all stuff you've seen before. Quadratic relation, parabola, vertex, axis symmetry, x-intercepts. It also could be called roots or zeros. So if you ever see zeros or roots, it's just an x-intercept. Okay, I'll try to remember to say x-intercepts, but I could slip out with a 0 once in a while here. And then we've got our 3 different forms of equations. We're going to be talking about them a lot today. And then we've got the quadratic formula. Okay, so what we're going to do today, first of all, summarize the key points or characteristics of a quadratic relation. So the most important for any quadratic is the vertex. That tells you the point, very important point, and it'll be used a lot when you work with word problems. It's either the highest point or the lowest point on the graph. And then the next most important point, the x-intercepts or the zeros. Let's take that out for now. And we just basically been talking about two techniques in order to find those. So the last two lessons have been all about that. Direction of opening, so some of these other things, I mean, we talked about these from the very beginning. So how do you know which way it opens, up or down? Hopefully you remember that's the A value. The y-intercept, how do you find that? I'll talk about that a bit more. Don't worry too much about this. Basically, you might need this if you're going to solve a word problem. You need to know, is it stretched or compressed, and what the factor is. And again, that's the A value. And the axis of symmetry, that comes from your vertex. Okay. And I said here, all these pieces of information, except for the other point there, are directly available from the values within the three forms of the quadratic equations. Okay, and we're going to talk about where do you get them based on what form you have. So remember the triangle we had about three lessons ago, the one that had factored form, standard form, and vertex forms, and the three corners, and how do you get from one to the other? Use these three processes: factoring, expanding, and completing the square. So these are the skills you need, or the tools that you're going to need to use for this lesson, and take that into the word problems as well. Okay, so everything that we've learned is coming together. This is just the organizing lesson. Where do you get the information? And then the next lesson will be the biggie, the word problems. So you're going to use these techniques. Okay. All right, so this is, it may seem a little difficult to understand how this works. I'll try to explain that for you. Basically, it says, given the graph of a quadratic function, it's possible to determine several pieces of information. And again, we're just listing the things from the last page. Now, down here, I've got those things I just listed on the previous page. So vertex, x-intercepts, direction of opening, y-intercept. This one don't worry about, stretch or compression, and axis of symmetry. So basically after this lesson, and after you practiced a bit, should be able to give you any quadratic equation in any form, any of those three forms, and you should be able to find all of these things. Okay? Now, the only thing that might not exist is the x-intercepts. So remember, sometimes, for example, a parabola could be above the x-axis and open up. In that case, it wouldn't have any x-intercepts. Okay, but all these other things, there will be an answer. Okay, and this one would have an answer, basically saying there's no x-intercepts, but all the other three things you can find the value of each of these things. Okay. Now, if I kind of summarize, where did we get these things from the equations? The vertex, standard, and factored forms. So if you remember, the vertex came from, this is the vertex form. Just put a V for vertex. It came from the H and K. This x-intercepts came from R and S in the factored form. Okay, direction of opening was your A value. So that actually came from all three. So standard, vertex, and factored gives you that directly. Now the C value, sorry, the y-intercept is interesting. We haven't spent a lot of time on this. Sometimes on the homework questions I've used this. Hopefully you've noticed. But if you want to get the y-intercept, where do you get that from the equation? And it's actually from the C value, from the standard form. Okay. Now you can get it from the other forms, but it's not directly available from the other forms. So I'll explain on the next columns how you would get it. stretch of compression, that comes from the A value, and the axis of symmetry. So again, this would be, don't worry about this one. This would be all three forms again, S, standard, vertex, and factored. And the axis of symmetry, that's your H value, that comes from the vector form, okay? Now, if you go over here to this kind of side table, you notice now, okay, so I'm still reading across here. So this would be how you would read this. So we've got three columns here for each of the three forms of the equation. And then how do you get, for example, this would be, how do you get the vertex from standard form? Okay, so if I gave you an equation in standard form, what would you have to do? So if it's in standard form, this is completing the square and finding h and k. You could also, I wouldn't recommend this as the best. You could also calculate h is equal to negative b over 2a. Now that only gives you h. In order to get k, you'd have to plug this into your equation to find what y is. Sorry, what k would be. So it's a bit of work, but if you just need that value h, then that's how you would get it. Okay. Now, say you not want to get the vertex from vertex form. Well, that's the best case because you just pull out h and k. Done. Okay. Now, factored form is an interesting one because you've got a few options here, and this is the way we tried to do it when we looked at factored form. You found the midpoint of the two zeros. Let me change that to x-intercepts just so it's find the midpoint of basically r and s. That gives you h. It's like h equals r plus s over 2. And then again, you'd figure out what the other value is. Okay. So we have done this quite a bit before. The other way of doing it is, if you remember the triangle, you go around the outside. Okay, so basically you would start with your factored form, you'd expand it, and then you'd complete the square like we did from here. Okay, so this tells you how do you get the vertex from any one of the three forms. That gives you the technique. So factored form, there's a couple of options there. All right, the next most important thing, how do you get the x-intercepts? Standard form. I would probably recommend using quadratic formula. That gives you it directly. That's a lot of work. The other way you could do it is factor and solve. Now, this isn't always possible, like we learned in the 2 lessons ago, right? A lot of times, standard form equations you can't factor. So I would say look at the equation. If it's easily factorable, then factor and solve, because that's always going to be quicker. But if you're not sure or it's going to require some work, I would usually go directly to quadratic formula. Okay. All right. Now, what do you do? How do you find the x-intercept if it's in vertex form? Well, this is where you go around the outside. Expand, so you change it to expand and use the quadratic formula, so you change it to standard form, and then basically you're here again. The other way to do it is you set you set y equals 0 and solve. We haven't done that very often. I'm going to show you how to do that. Well, maybe at the end of the next lesson, not today, but you definitely have this as your option: expand and use quadratic formula. Now, the third one, factored form, that's ideal to getting x-intercepts. You just use the r and s values. Okay, that'll be your 2 x-intercepts. Okay, and the rest of it's pretty straightforward. These are the vertex and x-intercepts. Those are the key things to find. They're always, when you do word problems, I would say 85% of your questions will be indirectly asking for these two things, okay? Occasionally it's, you know, occasionally it's the y-intercept, but most of the time these are the key things to find. Okay, now direction of opening, this should be pretty straightforward now. If A is negative, it opens down. If A is positive, it opens up. And you've got the A value in all three forms, so this is very quick. Y-intercept, that's the third most important characteristic or piece of information. So like I said earlier, in the standard form of a quadratic equation, the C, remember ax squared plus bx plus c, the C is your y-intercept. Okay, so if it's standard form, you can just pick it off. Now, what do you do if it's not in standard form? Well, in both cases, what you're going to do is you're going to expand it. If it's in vertex form or factored form, you're going to expand it back to standard form and just use C. Okay. Don't worry about that. Stretch or compression, again, that's just the A value. Remember, if A is between 0 and 1, it's going to be a compression. If it's bigger than 1, it's a stretch by whatever the factor will be A. Okay, and remember, if A is negative, the factor, you don't use the negative sign in the factor. You just say it's reflected and stretched by a factor of 2 if A was negative 2. Okay, axis symmetry, again, that comes directly from H, which is from your vertex form. So basically it's kind of, you want to find the H coordinate of your vertex. So again, this one the shortcut would be H equals negative B over 2A. And this one would be probably a lot quicker than doing that if you just want H. And then your axis of symmetry is X equal whatever H is. Okay. H is, if it's in vertex form, you just pick it off. It's H. And if it's third one, if your equation's in factored form, you could, again, you want to find the value of H, so it's the midpoint of the roots. So R plus S divided by 2. That's your H value. Okay, so that's probably what I do. So this is a good thing. I mean, you really should know, you should practice, and at least for vertex, x-intercepts, and y-intercept, be able to know, okay, how do I get those three pieces of information if my original equation is one of these three. Okay, that's really the goal of today's lesson. This chart will be repeated in the next lesson, which is the word problem, because a lot of cases we need to find this information, so it's going to be repeated. Okay, so there's a little bit of practice here. Normally what I do in class is have you guys partner up and give each other a quadratic equation in any of the three forms, and then basically you'll get that equation, and from that equation I want you to find the vertex, I really should change this is x-intercepts. Find the vertex, the x-intercepts, direction of opening, y-intercepts, stretch, compression, axis symmetry. So basically everything that's on that chart, I want you to be able to tell me from any quadratic equation in any form. Okay, so I just made this one up. You can see it's in vertex form, so right away you know the vertex, and you also know the axis symmetry. But most of the other stuff, well, we do know that also that it opens down because A is negative. We know the stretch factor, stretched by a factor of 2. So from that, we've got, if I go to the summary here, we've got, we got the vertex, that's 1, 8, H comma K. We know it opens down, the stretch and compression factor, and we also know the axis symmetry. So all we're really missing from this is what are the x-intercepts and what's the y-intercept. Okay, so I've already pre-done the work just so I could quickly go through it. So what do we do if we want to get the x-intercepts and we also want to get the y-intercepts? So first thing I want to do is, in both of these cases, I want to get it to standard form first. So it's expanding this. So x minus 1 squared is x squared minus 2x plus 1. Multiply that by negative 2 and add 8, and we get this. So negative 2x squared plus 4x plus 6 is our same parabola as the original, but it's in standard form now. And right from here, well, here's my c value now. That tells me the y-intercept. So I can go over here, add that to my list of things I know. And the only thing missing now is the x-intercepts. That's usually the hardest one. Okay, so there's two ways of doing this. Probably I would expect most of you would do this, this option, and that it would be set your equation, set y equal to 0, and then we're going to use the quadratic formula. So this is showing you the quadratic formula. A is negative 2, B is 4, C is 6. You plug that in, this is what we get. And this works out nicely because this is the square root of 64, which is really 8. And then we get two values, negative 4 plus or minus 8 over negative 4. So our two answers are x equals negative 1 and x equals 3. So those are the two x-intercepts. I can go over here, add those. Okay, and the other way of doing it would be if it's easily factorable. In this case, you could do it by factoring. So if I saw that, I go, hey, look, I can factor out a negative 2 here. When I do that, I get a nice simple trinomial that's easily factorable. So this x squared minus 2x minus 3 factors to x minus 3x plus 1. Okay, so if you notice, that gets you the same values, 3 and negative 1, as the quadratic formula did. So it's really up to you which way you do it. I would say, unless, like I said, unless you can look at that and go, if you get down to here and go, oh, that's easy, I'll just factor it now and I'm done. But like I said, a lot of times this is not factorable, and you do this work and you'd have to go and do this anyways. So if you're not sure it's factorable, I would probably go to quadratic formula. So at this point now, we've got everything that was asked. We've got vertex, x-intercept, y-intercept, opens down, axis symmetry, stretch and compression factor. So now we can go and we've got everything we need to graph it. Okay, I've got my two x-intercepts. I had to make this really dark just so you could see it. Two x-intercepts, the vertex, and just by looking at that, you can tell it's opening down. Also, the y-intercept is here, and that works out nicely. Now, the one thing that I'd recommend you using is these mirror points, okay, or reflection points. So the x-intercepts are already reflection points, okay, but this y-intercept also reflects. If you reflect over the axis of symmetry, you see another point right there. So there's a point at 0, 6. There's also a point at 2, 6. And when you have those 2 points, these 2 points, and the vertex, it's very easy to make your sketch of your graph. Okay? So that's it for the lesson. It's really how do you get all this key information from any quadratic equation in any form. So you should be really skilled at quickly going through and picking out the information and then changing it to another form that allows you to get the missing information. So in this case, we started with vertex form, but you could have easily started with standard form or factored form, and you'd have to go through another process to find out all the information. Okay, so I've got got some homework questions for you here, some from the textbook, but I'd also urge you to practice. Just take 3 equations you've seen maybe in previous homework. Find one from each format, one standard form, one vertex form, one factored form, and then find all the information you can. Just make sure you can do the steps that we practiced up here. Okay, not at, the sketch is the, that's just the icing on the cake, just to really see that it makes sense, that all your points seem to form a parabola. Sometimes you might do a calculation. For example, if you got the wrong y-intercept, it would not make sense that it goes way up here and then the vertex is lower than that. So this sketching is really make sure that your data that you collected makes sense. Okay, and then there's some homework questions, so you can try those. I'm going to post the solutions for this, not immediately, but later in the day on Wednesday night probably. So I do want you to try these, and then I'll post the solutions. I probably will be posting one more lesson, which will not be on the assignment this week. So remember, this week's assignment is just on solving quadratic equations, the last two lessons before this, and being able to find information like we did here. Okay, and that will be posted on Friday. Due Friday at 3, due Sunday at midnight. A bonus of 5% if you submit the assignment before 8 p.m. Okay, so that's it for now. Don't forget, if you have questions, please come to Thursdays 1 o'clock to 3 o'clock office hours. I'm a little bit underwhelmed by how few people are taking advantage of this. So that either means that you're not having any problems, or you're maybe not doing your work. So I have had some people say, I really don't get this stuff, but those same people never seem to reach out for help, and that's what these office hours are for. So take advantage of those. The people that have used it are really happy they had that option. Okay, so take advantage of it. It's usually one-on-one. I'll maybe get 4 to 5 people over 2 hours. So usually it's just you asking me questions and me showing you what to do. Okay, all right. So have a great day, and we'll see you on the next lesson.